Hello everyone, today we're going to be going over some sample math questions for the 9th grade SHSAT. These questions are from the 2022 SHSAT Student Handbook, which is made by the Department of Education, which are the people that make the test. So these are some questions that they select to kind of give you a feel how that math section on the actual 9th grade SHSAT will go. So we're going to start off by number 1. It says that assume s of x equals the sum of all positive even integers less than or equal to x. What is the value of s of 7? Right, so s of x here is going to be something that we call a function. And a function is it's pretty much sometimes is denoted by a letter and then in parentheses x. So for example, f parentheses x is a function, or f of x is a function, g of x, h of x, right? They're all written like this. Here, s of x is also a function. Usually when we see functions, they have clearly written rules. For example, when we see a function, we could say x plus 1. S of x is equal to x plus 1. And if we wanted to find s of 7, all we have to do is just plug in 7 for x. So s of 7 is equal to 7 plus 1. So whatever's inside of the x just shows you kind of the parameters you're working with. In our case, right, we're not given a clear-cut rule. What they give us is a bunch of words, and we need to translate those words into math, right? So here it says our function s of x is equal to the sum of all positive even integers. So here we're going to be adding numbers. So it's equal, the s of x is equal to this, plus this, plus this, and it goes on forever, right? But it's saying that it's the sum of all positive even integers less than or equal to x, right? So you're going to be adding these numbers that are less than or equal to x. So we know that when we add these numbers up, they're not going to pass the value 7, right? They're going to stop before we reach 7. Okay. Now let's see what kind of numbers we're adding, right? It's saying that we're adding positive, right? So there's no negative numbers. So the smallest number that we can start off with would be 1, because 0 is neither positive nor negative. So we're starting off with number 1 so far. And then it says, in addition to being positive, they have to be even, right? So now the smallest number I can start with is 2. And you might be asking me, well, why am I starting with whole numbers? Isn't the smallest number from 0, 0.0001 or 0.0002? I'm starting with whole numbers because it asks us, because it tells us that those numbers have to be both positive, even, and integers. What are integers? Integers are numbers that are not fractions. So they're whole numbers. They're whole numbers that can be positive or negative. In this case, they have to be positive. So it's positive, even, whole numbers that are less than or equal to x. In this case, s of 7 says that 7 is equal to x. So what are the positive even integers that are less than or equal to x? Well, our first positive even integer is going to be 2. It's not going to be 0 because 0 is not positive or negative. Then is 2 less than 7? Yeah, this works. But we could add another number. What's the next positive even number? Positive even whole number or integer from 2? It's going to be 4. That's the next even number. What's the next whole even number from 4? It's going to be 6. Okay? Now what's the next even number from 6? It's going to be 8. But look, it says that it has to be the sum of all positive even integers that are less than or equal to x. 8 is greater than x, or 8 is greater than 7. So we cannot include 8 in our summation, adding all this up. So all we had to do here was just recognize what a positive even integer is and what a sum was. And now the answer to our question is going to be 2 plus 4 plus 6, which is just equal to 6 plus 6, which is equal to 12. Number 2 asks us to multiply the square root of 16 by the square root of 169. These are perfect squares. You should know this off the top of your head. The square root of 16 is 4, and the square root of 169 is 14. Now, 14 times 4, that's going to be 6. That's going to be 1. And that's going to be 56. That's our answer. Number 3 says if line segment MN, whenever you see a kind of a flat hat on top of 2 letters, it means that it's a line segment. If MN is translated, whatever. I'll get into it later, but if MN is translated 1 unit to left to produce M prime, N prime, what is the area of the parallelogram that's formed? Right, so what is translation? Translation is a rigid movement in a specific direction, right? So if I translate 3 units up, that means that I'm taking a point, and I'm now adding 3 to that point's position in that direction. So because I'm translating something up, I'm adding it in the direction of the y-axis because the y-axis runs both up and down, right? So how would I translate this 3 units up? I would add 3, so I'd add 1, 2, 3. And now n is at position 4, where it used to be at position 1. So I just added however many units I'm translating it by. If I wanted to translate it 3 units down, I would subtract 3, or I would just move 1, 2, 3 units down, right? Same thing goes for left and right. In this case, they're asking us to translate it 1 unit to the left. So because I'm going to the left, I'm decreasing my position, so I'm going to subtract 1 from the position of n. Here, n is at x equals 5. So if I want to translate this 1 unit to the left, I move this 1 unit to the left. Now it's at n equals 4, right? Or I just subtracted 1 from the original position. The same thing goes for m all the way up here, right? M originally was at position 2. Now I put it at x equals 1. And now it's saying, what is the area of the parallelogram that's formed? And all you have to do is just connect the dots, and look, we now have a shape. So the area of a parallelogram is going to equal to its base times its height. Height is from top to bottom, right? So let's look at it. What's the height here, right? How many units is m from n? Well, n is 1, 2, 3, 4 units away from m. So our height is equal to 4. And what about our base, right? The base is just the length of one side, right? That goes from left and right. Here, m is the side that goes from left and right. This is 1 unit long, right? So our base is now 1. So our area is base times height, which is 4 times 1, which is just 4. So it's 4 square units. Moving on to number 4, it asks us to simplify p of 12 times p of 0 divided by p of negative 4, right? So for this, we need to remember some of our exponent rules. The first one we need to know is that any number raised to the power of 0 is equal to 1. 3 to the power of 0 is equal to 1. 4 to the power of 0 is equal to 1. Even if you have a mystery number p, right? Even if you have that variable there, it's still going to equal to 1 when you raise it to the power of 0. So p to the power of 0 is 1. So we could rewrite that as 1. And p to the power of 12 times 1 is going to be p to the power of 12. So I can really rewrite this as p to the power of 12 divided by p to the power of negative 4. Now, whenever I have two exponents that are being divided by one another, the rule is that I subtract them from one another. So in this case, p of 12 divided by p of negative 4, all I have to do is subtract whatever's on the bottom from whatever's on the top. So here I do 12 minus negative 4. That's all you have to do. For example, a to the third power divided by a to the first power, this is going to equal to a to the second, right? Which is 3 minus 1, which is equal to 2. Why? Think about it. You're just canceling whatever's on the top from whatever's on the bottom. A to the third is equal to a times a times a, and a to the first is equal to a. So you're subtracting how many a's are up here? 3 a's. How many a's are down here? 1 a. So you're subtracting 3 minus 1 because they cancel out, and you get a squared. That's why that rule exists. Anyways, you can just convert this into p to the power of 12 minus negative 4, which is equal to p to the power of 16, which is choice H. All right, moving on to number 5. Sorry about that. It says that water is pumped into a tank that is shaped like a right inverted cone shown above. The cone has a base diameter of 12 feet and a height of 4 feet. What is the volume in cubic feet of the water in the tank when the height of the water is 2 feet? Okay, so this is asking us about volume, right? And volume is just how much space is in a shape. This shape of this is going to be a cone, right? It's a right inverted cone. What does inverted mean? It just means it's upside down. Usually you see a cone, it's right side up. Here, in this case, the bottom is up, right? So they just flipped it upside down. Because they're asking us to find the volume, you need to remember the volume formula for cones, which is 1/3 r squared h, and then multiply that by pi. So it's, I'm gonna write this better because I just added a bunch of variables to that end. It's 1/3 pi r squared h, right? And it's asking us what is the volume in cubic feet of the water in the tank when the height of the water is 2 feet. So if I begin pumping in water, and this begins filling up with water, and that water reaches a height of 2 feet, let's say it's about there, 2 feet. What's the volume of this new water, right? So we know that our height is equal to 2 feet when we look at this problem, because the height of the water is 2 feet. But what's the radius of the water? Is it going to be 12? No, it's not going to be 12, because as you pump in more water, the radius of that water is going to increase, right? All the way up to up to 6 feet, right? But here we haven't reached that 6 foot mark yet, and we need to find the radius of this water up here. So how do we do that? We do that by setting up two similar triangles, right? Let's just draw out what we have here, and let's look at it like it's a 2D object. So here we have two triangles, right? This triangle has a height of 2 feet and a base of x feet. Now, if we just draw this a little bit higher, we now have a second triangle. This triangle, I'll just erase that. This triangle has a height of 4 feet and a base of 6 feet, right? Because 12 divided by 2 is 6, right? So let me just draw it out down here. I have this triangle, which is 4 and 6. And then inside of that, I have another triangle that's x and 2. And the way that you solve for x is by recognizing that these are two similar triangles, right? Look, they share two angles. They share this angle, and also the 90-degree that forms at the top. Doesn't really matter, but they're similar triangles. And how do you solve for a side on two similar triangles? Well, all you have to do is just set the sides equal to one another. So 4 and 2, right? This, you also set it up as two different fractions. So we're just figuring out where to put our numbers. 4 and 2 are both the height of the triangle, right? The 4 and 2 correspond to the side that goes up and down. So whenever you have values or sides that correspond to the same side, right? For example, 4 and 2 correspond to the same side, the side that goes up and down. You write them across from one another on your equation or on your two fractions. And now you do the same thing for 6 and x, right? 6 and x are both on the side that goes from the left to the right. So you write them across from one another. But which side do I write them on? Well, you write them on the side that they belong on. 6 belongs on 4's side because 6 and 4 are on the same triangle. And x belongs on the 2's side because x and 2 belong to the same triangle. And now that you have it set up like that, all you have to do is cross multiply. So cross multiply, you get 6 times 2 is equal to 12, and you get 4 times x is equal to 4x. Divide both sides by 4, and you get x is equal to 3, right? So now that we know that x is equal to 3, we now know the radius is equal to 3, and the height is equal to 2. Now we just plug it into our formula, right? V is equal to 1/3 pi r squared h. So volume is equal to 1/3 times pi times r squared. Here r is 3, so 3 squared is 9, times h, which is 2, which is 18 pi over 3. So v is equal to 18 pi over 3. 18 divided by 3 is going to be 6, and you just attach that pi, so it's 6 pi. Moving on to number 6, it says that the straight line L passes through the origin, as shown in the figure above. What is the slope of L in terms of A and B? So it's asking you to find the slope equation, right? How to find slope is just y2 minus y1 over x2 minus x1. This gives you the change in rise over run. What is y2 and y1? It's just two different points, right? So y2 can be this point, and y1 could be this point, right? So it's the difference in how much you increased in y over the difference in how much you increased in x. Cool. So in this case, what's our y2? What's our y1? What's our x2? What's our x1? Let's just assign values. Let's say that this is our y1. So 2b minus our this is our y2, and b is our y1 because we won't be left with a negative number. And this is now our x2, so 2a minus our x1, which is just a. So you do 2b minus b, you get b. You get 2a minus a, you get a. So your answer is b over a. All right. Moving on to number 7, it says the graph shows the wolf population in Yellowstone National Park since 2000. A student drew a line of best fit to model the data. Right. So what's a line of best fit? A line of best fit is supposed to show a trend amongst multiple pieces or multiple sets, not sets, but multiple points of data in a specific set. Right. So the general rule of thumb for a line of best fit is that the line has to be close to the points. Right. So it has to closely hug the points. It doesn't have to go through the points, but it needs to be close to it. And the second rule of thumb is that you need the same amount of points above the line as below the line, or a similar amount of points above and below the line for it to be considered strong, because this line is supposed to show the general direction that the data goes in. So these data points, if you have data points on a line, they're not going to follow a straight path, right? You can't draw a straight line through all of these without curving that line. But what you can do is you can draw a line that's pretty close to all of them, right? So you could almost say that, yeah, that line is kind of what the data looks like. So in this case, he drew a line of best fit. And it's supposed to show that as you increase in years since 2000, you decrease in the number of wolves. And you can kind of see that, right? The data up here, most of the data 2 years since 2000, right? You have wolves that are 150 wolves and 180 wolves, but 14 years after the year 2000, you only have 110 wolves, right? So there's definitely a decrease over time. But now we need to assess whether this line is strong or not. And we ask ourselves the question, is it close to our points? Well, the answer would be no, because look at these 3 points up here, and look at where my line is. And then look at these 3 points, and look at where my line is, right? It's not close at all, right? So that means that the line of best fit isn't strong because you have so many points that are far away from it, right? So the line of best fit is not strong because it does not pass through any of the data points would be wrong, because the line of best fit doesn't need to pass through data points. But it's not strong because the points aren't close enough to the line. So moving on to number 8, it says to determine the price of servicing a car, a mechanic charges a fixed fee plus an hourly rate for each hour he works. If his price for 4 hours of service is $270 and his price for 7 hours of work is $420, what is the fixed fee that the mechanic charges, right? So when we're determining the total price, our total price is going to equal to a fixed fee, so a fixed fee, plus an hourly rate, plus our rate times each hour that we work. So our rate times X. So total price is equal to fixed fee plus rate multiplied by X. So let's convert this into variables. Let's say that our total price is going to be T, right? So T is equal to our rate R, X, plus our fixed cost F. And now let's just plug in variables for these two, right? So we know that the total cost for 4 hours of work is $270. So $270 is equal to, actually, I'll write the other one first. So we know that $420 of work is equal to, $420 is equal to 7 hours, so our X is 7. So 7 hours times our rate plus our flat fee, or our fixed fee that never changes. We also know that if you work for 4 hours, which is just 4 times R plus our rate, you get $270. And now it's asking you what's the fixed fee. But you might be asking, well, how can I solve this, right? There's not enough information. Look at how I set up my two equations. I set them up right underneath one another. And notice how I can just subtract them, right? And look what happens when I subtract them. Our two flat fees get canceled out because F minus F is 0. 7R minus 4R is 3R. 3R. And 420 minus 720 is going to be 150. So now we know 150 is equal to 3R. Awesome, right? So now we know that 150 is equal to 3R. And now we can just simply solve for our hourly rate by dividing both sides by 3, and you're left with 50 is equal to R. But now the answer isn't 50. It's asking you for the fixed fee. So now you just plug in this 50 and solve for the F. So one of our original equations was 270 is equal to 4 times our rate plus our fixed fee. So in this case, 270 is equal to 4 times our rate, which is 200, right? Because our rate is 50. 4 times 50 is 200, plus our fixed fee of F. So subtract 200 on both sides, and you get that 70 is equal to F. So that's answer choice G. Number 9 says the rectangle PQRS above is rotated 100 degrees about the origin to form rectangle P prime, Q prime, R prime, and S prime. And now it's asking you what those coordinates of R prime are going to be, right? Yeah. Okay, so look, whenever you rotate something about the origin, 100 degrees about the origin, it doesn't matter if it's clockwise or counterclockwise because you end up in the same position, your coordinates undergo a specific transformation. You go from your coordinates being represented as x, y, into negative x, comma, negative y. That's all. So just know that when you rotate something 180 degrees about the origin, you negate your x and your y. So when I do this to my coordinate r, my original xy coordinate for r is equal to 4, comma, 3. And now, after I rotated 180 degrees, that x, comma, y is now going to be negative x, comma, negative y, which is now negative 4, comma, negative 3, which is going to be choice D. So just remember that rotation of 180 degrees turns it into negative and negative. So number 10 asks us, what is the quotient of the expression above expressed in scientific notation? So we have this expression which is asking us to divide these two numbers, and the question is asking us what's the answer to this, right? And it's asking us to express it in scientific notation. We'll go over that later. So whenever you have two things being multiplied one another in fraction form, you can separate it into two different fractions. So I can really separate this into 15.3 divided by 1.5 times 10 to the negative 8 divided by 10 to the 4. The same way that I can divide 2 over 3 times 9 over 9 into 2 over 3 times 9 over 9, right? Same thing. And they're both going to be equal to the same thing, right? You're just separating out the multiplication into two separate fraction islands, if that makes sense. So now let's do it, right? We'll simplify this because this is going to be easier. Remember in our one of our last questions, we went over what do when you're trying to divide two different exponents by one another. You subtract one from the other. So this turns into 10 to the negative 8 minus 4. So you subtract 4 from the end of this number. So 10 to the negative 8 minus 4 is really just equal to 10 to the negative 12. Pretty sweet, right? So now we already know our exponent to some extent. Now what we need to do is we need to focus on this 15.3 divided by 1.5. How do we do that? Well, we just divide it, right? So that's going to turn into 15.3 divided by 1.5. And to make our lives easier, I'm going to multiply my answer by 10. I'm going to multiply both of these by 10 because I don't want to divide by a decimal point. So I'm going to move all of these by 1 to the right by multiplying everything by 10. And I'm going to note that my answer is now being multiplied 1 by 10. So now I'm left by 15 divided by 153, and this is a lot less confusing to divide because I'm not dealing with any decimals, right? Any needless decimals. So 15 divided by 153. And notice how, because I multiplied by 10, I can just add that to my negative 12, right? Because what's negative 11, sorry, what's negative 12 multiplied by negative 10? Add negative 12 to 10, or to 1, and you get negative 11, right? So either way, my point here is that any differences in what my number is going to be expressed here. So if I'm multiplying by 10, I'm multiplying my final answer by 10, why don't I just multiply this by 10, right? That's also part of my final answer. And 10 to the power of 1 multiplied by 10 to the power of negative 12 is easy. They have the same base, so you just add the exponents together. So you get 10 to the power of negative 11, and I could stop here. I know that F is going to be my answer, because this is the only one with 10 to the power of negative 11 in the numerator place, right? If you divide this, you get 15 goes into 15 one time, right? 15 goes into 3 0 times, so you put a 0, and 15 goes into 30 2 times. So you get 1.02, and you just add on 10 to the negative 11. So the key takeaway here is you split these into two different fractions, and then you divide 15.3 divided by 1.5 by multiplying both of them by 10 and adding that 10 over here. Either way, even if you didn't do that, you would have been left with 10.2. And the issue with 10.2 is that if you want to express this in scientific notation, you can't have two digits to the left of your decimal point, right? You'll always need to have one digit. So I need to convert this into a single digit number. So how do I do that? I move a decimal point to this side. So I turn this into 1.02. And in order to convert this back into 10.2, I multiply it by 10 to the power of 1. But notice that my number already had 10 to the power of negative 12 attached to it. So that's why this turns into 10 to the power of negative 11. That's what we saved a step there. So which of the following expressions is negative in value, right? So negative number is not going to be positive, but that doesn't really help you figure that problem out. So either way, you get stuck with a negative number whenever you subtract a smaller number from a bigger number, right? So 2 minus 3 would give you a negative number. So you're looking for something that's smaller in front of bigger. 4 is wrong because 4 is positive. Pi is equal to 3.14. So 4 minus 3.141519, whatever, you're still going to be left with a positive decimal. 3 pi minus 9 is also going to be positive because you're multiplying 3.1415 times 3. So that's going to give you 9 and then some decimal point. So if you subtract that, you're going to be left with still the decimal point. 12 minus 4 pi is going to be correct because 4 pi in this case is going to be 4 times 3.141519. Yeah, so 4 times 3 is going to be 12, but you're also multiplying 4 by the decimal points that go on forever, which means that this 2 is going to be like 2.3437 or something. And 12 minus 12.3437 is going to give you negative 0.3437 and whatever's after that. Moving on to number 12, it says that in the figure above, triangle MPR is similar to triangle NPQ. If the length of line segment NQ is 10 centimeters, what is the length of MR in terms of X, right? So here we have two similar triangles again. Whenever you see two triangles that are written in one another, I want you to think similar triangle because that's what it is. So here, these two triangles are going to be related to one another in some special way. In this case, we need to find that relationship, and we need to express that. So we're trying to solve for line segment MR in terms of X, which is in terms of this one. So how are we going to do that, right? Well, think about it this way. We need to relate these two triangles to one another. And how do we do it in one of the last problems? We turned it into two different fractions that are equal to one another. And we said that the two sides that contribute to the same direction have to be across from one another. So in this case, 5 is running in this direction. It's kind of a diagonal up and down, right? And this contributes to triangle PNQ. Now we have another triangle, PMR, so this PMR, and the measure of this whole side, PM, is going to be x plus 5 centimeters, so x plus 5. Now we need to continue looking at this in terms of the bigger picture, right? Here we have 10, which is the side that goes from left to right. And now we need to look at side MR, right, which also goes left to right. So how do we find the relationship, right? It doesn't give us an x here. We don't know what it is. But what we do know is that these two triangles are similar and that each one of these sides is going to have some relation to one another. So we know that in this case, we can just represent this side, MR, as MR because it's asking us what is the length of MR in terms of x. So rather than actually solving for a value, you can just write MR. They're looking for MR is equal to 2x, or 2x plus 10, or x plus 5. The only way you can get MR is equal to that is if you write MR on the top, right? So we know that 10 goes from left to right. We know that MR goes from left to right, so they have to be across one another. We know 5 goes up and down, and x plus 5 also goes up and down, so they have to be across one another. And finally, the whole reason that we put 10 and 5 together is because 10 and 5 contribute to the sides of the same triangle. So now we just cross multiply and we get 10x plus 50 is equal to 5mr. And that, you just multiply both sides by 5 and you get 2x plus 10 is equal to mr. So here the trick was they wanted you to get confused. Oh, how do I represent mr? Represent mr as mr. That's all. Number 13 says the symbol x comma y comma z means xz plus xy over 2 plus zy. What is the value of 3 comma 4 comma 8? So it's saying that whenever you write numbers in this format, you want to write them like this, right? So for example, this is an expression. But instead of saying I want x equal to 2 and then y equal to 4 and then z equal to 8, I could just write it in this handy format right here. 2, 4, 8. And so long as I define what this is equal to, the people who are going to do this math for me know that, oh, this one is equal to x, this one is equal to y, this one is equal to z, and I just have to plug it into this formula. So all they're asking you is just identify which variables are which and plug them in. So in this case, we have this pointy thing, and it says that 3, 4, 8. So this is x, this is y, and this is 8. This is not, yeah, of course it's 8, but this is z. So now, knowing that x is equal to 3, that y is equal to 4, and that z is equal to 8, all you have to do now is just plug these into xz plus xy over 2. So xz is x times z, which is 3 times 8, so that's 24, plus xy, x times y, which is 3 times 4, which is 12, divided by 2. So 24 plus 12 is 36, and 36 divided by 2 is going to be equal to 18. So now we have 18 plus zy. Z is 8, y is 4, so it's 18 plus 32, which is equal to 50. Okay, and I believe that's all that the DOE gave us this year. Yep, they did. Okay, so that's all the problems that we went over. It's a bit of a long video, but I don't know how to make it any shorter. I'm really trying to cover all bases in these videos. If you like what you saw, please subscribe, leave a comment, like the video. If you have any questions, also leave them in the comments. If you want me to go over any specific problems on any practice tests that you have, also, again, leave them in the comments. I can go over them. Other than that, I hope you learned something. I hope you have a nice morning. I hope you have an awesome day, and I'll see you next time.